So I have this box. I'm going to be trying to package this thing here inside of it. It cannot go crossway, it can't go straight, it just can't fit. So I'm going to try to resize this box using the factorization method to get it done. Watch me. So you see that the item actually fits inside the same box perfectly without any fight, any hassle. And this is a mathematical process called factorization. It's easier done than said, but once you get into the practice of doing it, which I'm going to show you, it's going to be so easy and fun. You might enjoy doing it too, but this is how we use it in real life. And for me personally, factorization is about breaking big geometric shapes down into more smaller ones that are easier to deal with. So seen in the instance that we had this big old box that this item couldn't fit in properly at all, no matter how we put it diagonally, we put it straight, it just couldn't fit. After using some math and using factorization, which was really to break down the different sides of this rectangle into a smaller one, we see that the item can actually fit easily. See there? Just like that. Try it one more time just so you can see it. See there? It just slipped right in. So I'm going to show you how to use factorization in algebraic terms. Here we have an example that says factorize completely. And to factorize something completely, we have to use what is called the highest common factor, which is a number that can go into both terms equally. So we have 2x plus 6, and this represents a rectangle. So what we need to do is to rewrite this as a product of two terms. So we need to factorize it using the highest common factor. So we need to look at the 2x and the 6 and determine what can go into 2x and 6 without leaving a remainder. 2 can go into 2x and 2 can also go into 6. So I'm going to pull out the common factor, which is 2, and then I'm going to open up a set of brackets. By this common factor, I'm going to divide both terms. So notice that 2 can go into both 2x and 6. So I'm going to divide both 2x and 6 by that common factor, which is 2. And it's the highest common factor. So 2 into 2x, these cancel, leaving us with just x. And 2 into a positive 6 goes positive 3. So when I rewrite 2x plus 6 by factorizing it, I will end up with 2 bracket x plus 3 close bracket. And if I want to check that it's correct, I could multiply the brackets out to see if I get the original expression. So 2 times x will give us 2x, and 2 times 3 will give us 6. Easy, don't it? Let's see if we can do another example with the numbers. So I'm going to put, let's say, 10a plus 15. The two terms we're looking at is 10a and 15. What can go into 10a and 15 without leaving a remainder? 5 can go into 10a and 5 can also go into 15. So 5 will be the highest common factor that I'm going to pull out. When I pull it out, I'm going to create brackets. To get what's going to go inside the brackets, I need to divide both terms by that highest common factor of 5. So 10a divided by 5, that's going to give us 2, because 5 into 10 goes 2 times. But look, we're also left back with that a. So I'm going to have 2a. If I multiply it out, I'm going to get 5 times 2a, which is 10a. So this is correct so far. Now I have positive 15 divided by 5, and that will give us a positive 3. Let's multiply it back to check it that it's correct. 5 times 3 will give us 15, and that's 15 right there. Let us look at these two examples. We're factorizing completely first, ax plus ay. We're looking for the highest common factor. That means something that is in both terms. So when I look at the ax and when I look at the ay, what is common? What do both of them have that are similar? A. So a would be the highest common factor. So I'm going to pull that a out by saying a and creating some brackets. Now you remember what we do with the highest common factor? We divide the terms by it. So I'm going to divide ax and ay by that common factor of a. If you don't divide the two of them, then it's wrong. So you have to make sure you divide the two of them. Or if 3 of them are there, you divide it by the 3 of them. You divide the 3 of them. If 4 of them are there, continue the pattern. So let's go. So this ax divided by a will cancel here, leaving us with just x. And this positive ay divided by a will cancel that, just leaving us with this positive y. So when I factorize ax plus ay, I will end up with a bracket x plus y bracket. Let's look at this last one. What is common between xy and minus zy? When you sound it out, you know, the answer kind of comes straight to you. So what's common is this y. So I'm going to factor out that y, and I'm going to be left with a bracket, with some brackets. And if I'm factoring out something, it means I'm going to have to divide the original by it. So I'm dividing the original by this common factor of y. When I cancel that out, xy divided by y will just give us x. And this minus zy divided by y, these cancel, just leaving us with this minus z. And that's it. You know, sometimes life comes complex and complicated, and so do some of these math problems. But guess what? The basics still applies. We'll look for the highest common factor and just divide it right through. Let's look at this one. 6xy minus 15xb. Let's look what is common. I'm going to start off with the numbers first because it's easier for me that way to just look at the numbers first. Right? So I have to ask myself, what number can divide into 6 and 15 at the same time without leaving a remainder? When I check my timetable, it is 3. 3 can go into 6 and 3 can also go into 15. So the first part of the highest common factor for me would be 3. So now that we looked at the numbers, we can look at the variables or the letters now. So we have x, y, and we have xb. What is common between xy and xb? X. So I'm going to pull out that common factor of x. So straight away now, I'm finished with the variables, the letters, and I'm finished with the numbers. So the highest common factor between 6xy and minus 15xb is 3x. Now that I've found the highest common factor, I'll just follow the basic steps. Open up my brackets, and then I'm going to divide both terms by that highest common factor of 3x. Alright, watch your drama now. 3 into 3, 1. 3 into 6, 2 times. This x cancels that x, so on the left side, I'm left with 2y. Just check it as we go along. So 3 times 2, that's 6, which we had. And x times y give us xy. So 6xy. So far, we're good. Let's go over to the other side now. So we have this minus 15. You know what? I'm going to just put a minus there in our highlight because trust me, good. So I have that minus 15 and we're dividing by 3. So I'm starting with the numbers first because it's easier for me that way. If you have a different method, as long as we get the same answer, we're good. So I have minus 15 and we're dividing that by 3. So negative divided by a positive should give us a negative. Good. And 3 into 3 goes 1. 3 into 15 goes 5. Good. So I have the 5. The x is common at the top and at the bottom, so I'm going to cancel those. So I'm left with 5b. So I'm going to just drop on the b on that. So let me just multiply them back out to see if I get the same thing. So 3 times minus 5 will give us minus 15, which we originally had in orange. And then the x times b will give us xb. So we're good. This is how you get it done. You want another example? Alright, let me just try another one. Let's say 4a squared plus 6ab. So the drama they know, but no, nobody remember the first part. Alright. What this means is 4a. You can say it that way. So 4a squared is the same thing as 4 times a times a. This index tells us how many copies of this term or variable exist that is being multiplied. So that is why I have AA here, but when I usually say AA, but it can work. So I'm going to rewrite the indices this way. So a squared becomes AA and then 6AB. I'm doing this to just illustrate a clear point. Since we finished rewriting it that way, all we have to do is to look for the common factors between the numbers and the letters. And I'm going to start off with the numbers first. So what number can go into 4 and 6 without leaving a remainder? 2. Alright? Because 2 can go into 4 and 2 can go into 6. And it's the highest number that can go into 4 and 6. Remember that. Alright? So let's look among the variables now. We have A, I will have AB. What's common? The A. 1A is here and 1A is there. If there was 2 A's on both sides, you just use the 2A, which would have been A squared. But it's just 1A that is common between both terms. So I'm going to pull out that A. Then I'm going to open up my bracket and close it. Remember what we're going to do now? We're going to divide both terms by the highest common factor, which is the 2A. So when I do that, 2 into 2 goes 1 and 2 into 4 goes 2. 1A at the top cancels 1A at the bottom. So I'm left with 2A on the inside. See here, 2 and A. Let's go over to the next side. So you have a positive 6 and you're dividing it by 2. 2 into 2 goes 1. 2 into 6 goes 3. So that's a positive 3 so far. We're not done yet. You have 1A at the top that cancels 1A at the bottom. And look what we're left with on the outside. 3b. So we're supposed to see in the bracket down here 3b. Good. And that's it. If you want to check it to make sure that you're correct, go ahead. 2a times 2a will give us 4a squared, so that is good. And 2a times 3b will give us 6ab, because 2 times 3 is 6 and a times b is ab. So this is how you get it done.